Well, let me start backward. Last time we said, let's say I'm giving you f of x, y, and z. And I said, this is the summation of the minterms of 1, 5, 6, and 7. I just made that up. Can you find the expression for it and simplify that expression? So here we go. We have 3 inputs. What's 2 to the third? 8, right? We should have 8 combinations. This is the label, okay. This is 1, 2, 3, 4, 5, 6, 7. Makes it easy on the eyes when you have the lines. 8. I have 3 inputs. The inputs are x, y, and z. It says f of x, y, and z. 1, 2, 3, 4, 5, 6, 7, 8. I should have 8 different combinations. So the choices are to list all the possibilities. 0, 1, 0, 1, 0, 1, 0, 1. 0, 0, 1, 1, 0, 0, 1, 1. 4 zeros and 4 ones. That covers all the possibilities for x, y, and z. There are no other choices. Now f, what this one is telling me, f is going to have a value of 1 where?
1, 5, 6, 7.
F is going to have a value of 101. This is the 1. This is the 5. This is the 6. This is the 7. That's the minterms. That means the rest of them will be what? Zeros. So for this one to be 1, let's look at this one, the 1. To be 1, the minterm for that, you want to have what? X bar, Y bar, and Z. You want to have an AND gate with X being complemented, Y being complemented, and 0 alone. When you put 0, 0, 1 to that AND gate, you complement the 0, that's a 1. That's a 1. 1 and 1 and 1 will give me what? 1, and that's why you get that 1 there.
Would that expression always be written for an AND gate?
Correct. For the minterms, always an AND. A minterm is an AND gate. Max term is an OR gate.
No, I mean for like the f, x, y, z equals...
This notation, yeah. Once you see summation, that means it's OR gate. It's the multiplication of OR gates, minterms. The minterm is actually AND gates, and you're going to OR them. You sum them. So now this one, you're going to have a value of 1 when x is what? You want x to be alone, y complemented, then z. When it's 1, you leave it alone. When it's 0, you complement that. For the 6, x is 1, y is 1, z not. And for the 7 is what? X, y, and z. So you can write now f of x comma y comma z as the sum of product, which will be x bar, y bar z, plus x, y bar z, plus x, y, z bar plus x, y, z. And if you want to simplify that, go ahead. How do we simplify that? Well, notice x, y, z. I can put more than one. An OR gate with a plus a is always what? An a. So I can write this x, y bar, z plus x, y, z. I added one more x, y, z. Notice I can take this and this and simplify them. I can also take this and this and simplify them. So I said, why not just rewrite this one more time? Why not add this?
You could have just simplified the first two and had.
I could, yep, I could actually. I didn't see that. Absolutely. I did not see him. But I could have done that without having to add this one. Wouldn't make a difference. Some of you notice these two, the y bar and z will stay there. X and x bar will be gone. So you end up with what? Y bar z, and this one will have xy. And you're done. I did not see it. So if I do these two, I'll get the same answer at the end. If I do these two, what will happen? xz, right? Because you factor xz, what's left? Y bar plus y. And this one, you factor what? xy. And you have z plus z bar.
Couldn't we factor out the first one because it matched with the second one also?
You could. I just said I didn't see them. These two?
Yep.
That's what somebody recommended. I just didn't see them when I was looking initially.
Could you just add another one so that you could simplify the first one?
Actually, if I took these two and these two, it would be perfect. I could do this. Well, I can use it right here. I can simplify it even right here. Because this will be what? Z times x bar. I can put the x first because the format I'm going to show you in a second. Let me write that piece first. Put that one. And we have one of these rules that says x plus x bar y can be written as x plus y bar. Where is that? One of the rules, right here. A plus a bar b can be written as what? A plus b. 10a, can you see it? So if I use that here, I can write this x plus y bar which is xz plus y bar z plus xy, which I probably didn't do a good let's see, didn't do a good job because that's 3 terms. So probably that wasn't the best move I did there. Because if I took these two and these two, how many terms would I have? 2 terms. As I said, I didn't see it first till somebody brought it to my attention. Go, why don't you take the first two? Because if I took the first two out, you will have what? Y bar z times x bar plus x, which is what? 1. Plus, if you take the last two, you can take xy out, and z times z bar, which is what? 1. So you end up with y bar z plus xy. Notice what I have here. I have the y bar z, I have the xy, so what's the xz doing here? I have an extra piece. So that approach, what I did there, it wasn't really the best move there. I can try to add another one, see if I can simplify it. I can say, well, somebody said, what about if you add x bar, y bar, z to the list? Well, if I add another one of these, is it going to simplify this one?
You'd have to add the X, Y, Z.
So that will make the Z, X will be X plus Y bar. Let's see if we will, you know? Because I end up with 3. Somebody recommend adding this term, the first term, write it twice. I'm making way more work for me than if I saw that early. Notice how quick. So now when you look at these two, you go, I get to factor Z out. What's left? X plus X bar, Y bar. X plus Y bar. It didn't help me. Why? Because that gave me what? XZ plus Y bar Z plus Y bar Z plus XY. What's Y bar Z plus Y bar Z? Still a 1. I mean, still Y bar Z, one of them. That didn't help me. So that wasn't really the best move for me. The best move was to grab the first two and the last two. That was the best move.
Are you gonna give us any with like 4 variables?
You can have 4 variables.
But like for the test next week, are you going to or no?
Ah, well, since you asked that, let's try some. Okay. I don't know. I didn't decide what's going to be on the test, so I hate to tell you I'm not going to do it or I'm going to do it. I use graph paper, so I'll be less line. Let's say we have f of a, b, c, and d equals the summation of the minterms of 0, 5, 9, and 15. Now I have no idea if they can be simplified or not. I'm just making things up. Now I can make the truth table and go through it, but then I will have how many combinations here? 16. I use the graph paper, so I could probably do A, B, C, and D. These are the labels. And I'll try to break them groups of 4 so I can look at them. I'm going to do groups of 4 so I get to see them, and I'll put a dotted line between them.
Couldn't you also just, if you know what 0,
Yep,
5,
I can go directly to them, and that's what I'm going to be doing soon. But now I'm just going to go 0, 0, 0, 0, 0, 0, 1, 0, 0, 1, 0, 0, 0, 1, 1. That's the first 4. I'll put a dotted line to separate them just to make it easy on the eyes. Then 0, 1, 0, 0, that's a 4. 0, 1, 0, 1, that's a 5. 0, 1, 1, 0, 6. 0, 1, 1, 1, that's a 7. That's the next 4. After that, 1, 0, 0, 0, 1, 0, 0, 1, 1, 0, 1, 0, 1, 0, 1, 1. That's the 11. 8 through 11. And finally, 1, 1, 0, 0, 1, 1, 0, 1, 1, 1, 1, 0, and 1, 1, 1, 1. That's the 15. I broke them into 4 just so I can see where I am. It's easy by looking at it to see where I am instead of just leaving all as one group there. And this is my F. F has a value of 1 where? At 0, at 5, at 9. 9 is what? 8 and 1, that's 9. At 15. And the rest of them are zeros. So the minterm for the first one, when you write that, since they're all 0, is going to be what? Oh, I'm using A. A bar, B bar, C bar, D bar. You want AND gate with all complemented, all the inputs. This one, A bar, B, C bar, D. This one, A, B bar, C bar, D. And the last one is what? A, B, C, and D. So if you want to get your function now as sum of product, it's going to be A bar, B bar, C bar, D bar, plus A bar, B, C bar, D, plus A, B bar, C bar, D, plus A, B, C, D. That's C bar here, not C. So that's the expression. And you work on Boolean algebra to see if you can simplify it.
There's another way to do that?
Huh?
You said there was another way to do that?
Yep. So now you have to work with Boolean. Can I take this and simplify it? Not really. I can factor out A bar and C bar. That doesn't do me any good. How about these two? Nope. Nope. I can factor C bar and D, but I have A bar B and A B bar. Nope. I can take this and this. No. I can factor A and D. That doesn't do it. This and this. No. I'm stuck. Can't simplify it. Now, I could have put more ones here trying to simplify it. Put a 1 here, put a 1 there, and maybe I'll be able to simplify it. But not the way it is right now. But that's the 4 variable. I went from giving you this expression to the table, the truth table, from the truth table to the expression. Now, do you have to make this one up? The question was, do I have to make that table? No. If you know what the binary value for 0, 5, 9, and 15, you can get to that. You could have just said, I have 4 variables. I don't have to make the truth table. For 0, it's 0, 0, 0, 0. For 5, it's 4 and 1. For 9 is 8 and 1, right? And for 15, it's 1, 1, 1, 1. So this is your A, this is your B, this is your C, this is your D. That's A naught, B naught, C naught, D naught. That's the first one. This one, A naught, B, C naught, D. That's this one. For the 9, A, B naught, C naught, and D. And for the last one, A, B, C, D. So you don't have to make the table. If you know what the binary value for 0, 5, 9, 15, you'll be able to get the expression. Especially when you have a lot of them. I don't want to make a truth table of all these values. Where you might have a problem sometimes is giving you the table, and, well, not the table, giving you an expression, says change it to that. So here's an example. F of A, B, and C is equal to A plus B bar C. And I want you to write that as F of A, B, C equals to the summation of the minterms. And tell me which one. And maybe while I'm at it, how about we'll do the product of sum, the max terms. So this is the sum of product. This is the product of sums. How do you go from this to this or to that one? If you know this, you know this. Just like this, I know when the function is 1. Can you tell me when the function is 0? Yes. At 1, 2, 3, 4, 6, 7, 8, 10, 11, 12, 13, 14. When it's now 1, it's 0. But how do we go from this one to this now? I can do the same thing. I can go A, B, C. That's where the truth table comes in now. Let's list all the combinations. 0, 0, 0, 0. Oh, 3 of them. Why have 4? 3 variables, right? 0, 0, 1. 0, 1, 0. 0, 1, 1. 1, 0, 0. 1, 0, 1. 1, 1, 0. 1, 1, 1. It is F. These are sum of product right now. Simplified. That tells me the function will have a value of 1 when what? Let's look at this guy. You'll have a value of 1 when A equals what? A equals 1. Let's find out what A equals 1, which is the last 4. Or when?
B bar C.
When B is 0, C is 1. B is 0, C is 1. That's an AND gate. So where is B is 0, C is 1? Right here and right here. I already have 1 here, so the rest of them are zeros. So you will have a value of 1 when A is 1 or B is 0 and C is 1. Find out where A is 1 and mark them as 1. Find out where B is 0, C is 1, and put a 1 there. So now I know what the minterms, that's going to be what? 1, 4, 5, 6, and 7. The max terms, that's where the zeros are, where? At 0, 2, and 3. So if you want to write the sum of product before you simplify it, so it's going to be a 1 here, so that's A bar, B bar, C. Add to it, that's 1. Right here, A, B bar, C bar. Add to it. The 1 here, A, B bar, C. Add to it A, B, C bar. And add to it A, B, and C. I can use my math to simplify it, but if I simplify it, I go back to that one. I see the last 2,
First 2.
and I was looking at these 2 actually, but you could use the first 2. Yeah, no, I can't, these 2, right?
Yeah.
The middle 2, and these 2. If you look at these 2, I see what? A, B bar? This one. Why? Because you'll have C bar plus C. What is C bar plus C? 1. You look at these 2. What do you have? A, B. What's C bar plus C? 1. Now, oh, I know I have 2 plus signs. Let's look at these 2.
You can factor out the the B bar.
You mean the A?
Yeah.
These two. If I factor an A, what's left? B bar plus B, which is 1. And we have a rule that says what? X,
It's also A bar, B bar, C.
yep, X bar Y can be written as what? X plus Y. That's one of the rules. So when you look at them, this is A, that's your X, plus A bar, and Y is really BC. That's what Y is. So X plus X bar Y. So I should be able to write that as A plus BC. Is, missing a bar somewhere?
Yeah. You
Yes, I forgot the bar here. Yep. So it should be A plus B bar C.
That's awesome.
Yep. If you were to write this one, remember, this is the product of sum. You're going to have a 0. So you want your answer to be 0. Be careful here. If it's 0, you leave it alone. So for max terms, when you write this is A plus B plus C for max terms. Because you want that sum to be 0. You want an OR gate with A, B, and C going to it. That will give me a 0. 0 or 0 or 0 will be a 0. I need it right here. So that's A or B bar or C. And the last one with these is this one. A bar plus B plus C. So for max terms, we use capital letter usually.
Wait. Don't, you switched it for the last one. Doesn't it need to be A plus B bar?
Yep, A plus B bar. The ones you complement, the zeros, you leave them alone. Yep. So for that will be what? A plus B plus C, and it with A plus B bar plus C, and it with A plus B bar plus C bar. And you can simplify that. Notice I can write that term twice, because I can take it with this. Is that the term, or this term twice? I can write that term twice, because I can take these two guys. Let's see if that will simplify.
Why can't I get twice? I'm still okay.
What?
I'm taking that twice
Because you'll see I'm going to do it in a second. I'm going to grab that middle one and write it twice. So I took the middle term, I wrote it twice. Here's once and there's twice. The reason I was thinking about that is right here. Notice they have what? A plus C. So you can write that A plus C plus B. And the other one is what? A plus C plus B bar. X plus Y ended with X plus Y bar, we said is what? X plus Y. Where's that one? Which rule? Where'd you go? Where is it? Where is it?
P11?
P11? That's double complement, no? Oh, right here. 9. A plus B bar is equal to what? A. That's what I'm using. A is A plus C here. So this is the B and that's the B bar. So these guys, you end up with A plus C. And if you grab these two, Notice I have what? A and B bar in them, so I can write that A plus B bar plus, forgot the plus here, plus C bar, bless you, A plus B bar plus the C. And now again, that's the same Boolean algebra. I can write that as A plus B bar. So if you want to put your answer as the sum of product, there's your answer as sum product. Now watch this. If you distribute that, if you do the math, just to show you that's really the same expression as this one. So this is my simplified what? Product of sum. Where was the other one? Earlier, was that it, this one? This is my simplified sum of product. But if I take this and FOIL it out, what's A and A? A plus what? AB bar plus AC plus B bar C. What happens to all these three? You can factor an A out. What's left? 1 plus B bar plus C. What's 1 ORed with anything? 1. So that's equal to what? A plus B bar C. Was that the same expression? Yep. So the sum product or the product of sum, this one tells you when the function is going to be 0. This one tells you when the function is going to be 1. It's the same thing. If I'm telling you where the function is 1, then you know where it's going to be 0. If it's going to be 1 of 4, 5, 1, 4, 5, 6, 7 is going to be 0, 0, 2, and 3. So I can give you either one and get both answers, the product of sum, sum of product. If you can go to that table, rewrite them, and do Boolean algebra.
One other thing I was forgetting a lot. How do you rewrite the, because the term's already in there?
For the Minterms, you want to tell them when the function is going to be 1. It's an AND gate, so for this to be 1, you want to complement that.
Oh, I meant,
You want to complement this and C. I'll come back. This is A, leave it alone. That's B bar, C bar. This is A, B bar, C. This is A, B, C bar. And this is A, B, and C. And that's why this function has all these in it. For the max term, that's when the function is 0.
I was asking them, how do you add a term, because it's already in there, in the second one, in the product of sum?
Here?
Yeah.
What about it? Where'd you get these numbers?
No, where did you get, when you go down to the equation, I
He-
forgot how you added a term.
Oh, I took that, because I was trying to simplify the algebra. When I was looking at it, I said, you know what? This and this I can take out. If I decide to do these guys, I can factor AC out, and you have B bar plus B. Then I also saw if I take these two out,
You can just add the term because it's
sure,
already there.
it's a multiplication. You're multiplying by 1.
Okay, sorry.
So, because B or B, B and B is the same as B, B or B is the same thing. That's this rule. A and A, where's A and A? A and A is still A.
Yeah.
And also A or A should be A. Somewhere here should have A or A. Where is it?
P6, right?
Right there.
Yeah.
So if you add a term or multiply by the same, just add another term, just multiplying by another term, it doesn't change the value of the expression. I can either use it for multiplication or addition if they help me simplify.
Okay, thank you.
You're welcome. So that's where it came from. But that allows me to go back to the table. Once you get back to the table, the truth table there, you can really come up with everything you want to find. Or you could have a circuit there and say, oh, can you tell me what the expression for, with the truth table, the minterms, the max terms. Let me see if I can find a circuit. I don't know, I'll just take one. I don't want to take a huge one. A, B, C, D, E. That's not good. That's too many of them. A, B, D. That's 4. Okay. I got 4 of them. Let's take this circuit and see if I can actually find what the truth table just by looking at the circuit. I have C.
Which one is this one?
I'm looking at page 87. I just taken a picture from it.
Is it A or B?
B. I don't like A because there's too many variables. I don't want to do a truth table that big. I have an AND gate here. And this one attached to is actually A. You can see the A is attached to it. The C is attached to it. I don't know why I made the wire so long here, because they put it here, so I can just move it here and just write C next to it. Make my life easy. The next one. You have another AND gate here. Attached to the AND gate. Another AND gate here with 2 inputs. The 2 inputs for it, B bar A. Here, it's an OR gate. Attached to the OR gate, oh God, an AND gate. And one of them is C bar. The other one is another OR gate, and attached to it A and B. And what else attached to the OR gate? Another AND gate. And I should be done with this, C and D. And that's my function F. Now, if you want to find the expression for that, and we can come up with a truth table for it, what is the answer right here?
AB,
Try again. That's an OR.
A plus B.
Yep, A plus B. That's an OR gate, in case you can't read it. This is an AND between this and this, so that'll be what? C bar times A plus B. This is an AND gate. That'll be what?
CD.
CD. And this one's going to OR them, so that'll be CD plus C bar A plus B. This one, that's an AND gate. That'll be what? A, B bar. And this one's an AND gate of this and that. That means multiply them. So that's A, B bar, multiply it with CD plus C bar A plus B. And what's this one? That's an AND gate. That's AC. So what is my F here? It's the OR gate, the addition of this and this. So it's AC plus A, B bar, CD plus C bar, A plus B. You can make life easy on yourself.
If it's neat.
Well, if it's neat, yes. Or if you distribute that C bar. If I distribute that C bar, I will have what? A C bar plus B C bar here, plus what? C and D. Multiply that with A B bar. So it's AC plus, let's distribute that, that'll be what? A, B bar, C, and D, plus, still you have the A there, right?
Yep.
A, B bar, C,
Maybe C bar or
And
just
B
C?
bar and
C bar, yeah.
cancel.
And B bar will cancel each other out. Notice when you distribute that, it's going to be A, B, B bar, C bar. It's an AND gate with 1, 1, 1, 0, B and B bar. So that's it. So when you simplify the expression, is that what we got? Now, if that's the case, guess what? I don't need that term. Because if you look at the math there, if you were to design this circuit, I want to give the minterms, but if you were to design this circuit, what do they have in common? Not just A,
AC.
AC. If you take an AC out, what's left? 1 plus B bar D. I don't care what B bar and D have in them, as long as you OR them with 1, what's the result? 1. That's an AC plus A, B bar, C bar.
Do you still want to add a C bar
AC.
to the middle one?
Did I leave anything out? What are you talking about?
Where you distributed a B bar?
I multiplied that, right?
Yeah, lower
So
one.
A, B bar.
Push below that.
Here?
Yeah, don't you still want to add a C bar at the end?
No, because B bar and B is what?
1.
0.
0.
Oh, okay. Yeah.
That's gone.
And that's,
Now, I'm not done with this. I can factor out what? A out. What's left? C plus C bar, B bar. I wrote it this way because we have one that says if you have C plus C bar, B bar, you can write that C plus B bar. So really, that circuit that you see there, I can replace it with 2 AND gates. One has A and C going to it, another AND gate, and this one has A, B bar, and what do you want to do with them? OR them together. This is equal to that circuit. Where I was going with this, I wanted to get the truth table, which give me a minute, and I'll give you the minterms and the maxterms. I have 4 inputs, A, B, C, D. That's why I chose this problem. So I will have 16 different combinations. 0, 1, 2, 3, 4, 5, 6, 7, 8 sets of 0, 1, 0, 1, 0, 1. 2 zeros, 2 ones, 2 zeros, 2 ones, 2 zeros, 2 ones, 2 zeros, 2 ones. 4 zeros, 4 ones. Graph paper is wonderful there. And 8 zeros and 8 ones. I'm almost done. And this one tells you when you're going to have a value of 1. This is F. According to this one, according to my expression, F is going to be 1 when A is 1 and C is 1. Find out where A is 1, C is 1. A is 1, C is 1. A is 1, C is 1. A A is 1, C is 1. Can you see it? 4 of them. Also, when A is 1 and B is what? 0. A is 1, B. By the way, if you design it the other way, it'll be even less, because that's an OR gate with one AND gate, if you went to that design. Because isn't that one OR gate? And it with another gate. So it's, instead of even using 3 gates, you'll need 2 gates. So when A is 1, B is 0, where is A 1 and B 0? Right here, right here. Right here, right here. That's it. The rest will be zeros. So you can write that as F of A, B, C, D equals the summation of the minterms. Where are the ones? What location? 8, 9, 10, 11. 8, 9, 10, 11. What else? 14 and 15.
How did we figure out how we got 8, 9, 10, 11?
That's where the ones are.
Oh, so the ones, okay, to the A's.
And max terms, that's where the zeros are. It's when you see the product of max term, that's where the zeros are. The 0 where? 0, 1, 2, 3, 4, 5, 6, 7. 8 is gone, 9 is gone, 10 is gone, 11 is gone, 12 and 13. That's where the ones, that's where the zeros are. So we took that problem from a picture, created the expression, simplified it even, we didn't have to, but simplified it, went to the truth table, made the truth table, came up with the minterms and the max terms. Okay.